SCIDIP-ES RepInfo Toolkit is a graphical editor for editing RepInfo network models. It enables us to load RepInfo networks from SCIDIP-ES registries, edit them, store modified networks back, and provide support for creating new RepInfo objects. Let's introduce some of the concepts. A RepInfo network is a dependency or network graph containing a set of RepInfo data objects, or RIDOs for short, that are defined by the preservation archive to help their target users to understand and use the data associated with the RepInfo network correctly. In our tool, each RIDO captures information about the RepInfo and the relationships between them. The two types of information are stored in the SCIDIP-ES registry as a manifest, a pointer to the RepInfo, and a RepInfo label or RIL, which captures the relationships. In the tool, we use the name graph label instead of RIL to describe the graphical relationship between a RIDO and its immediate children. A self-contained RIDO will contain both kinds of information: details of the RepInfo object itself and details about the graph label that relates it to other RepInfo objects. In the tool, the RIDO at the top or root of a graph might contain only graph label details, and the RIDO at the bottom, which is a leaf of the graph, will only contain RepInfo or manifest details. In the registry, every RepInfo object must have a graph label to describe it in terms of other objects. So whenever we create a new RIDO, we should provide a graph label, or we won't be able to upload it to the registry. There is a special manifest for missing RepInfo that can be used when we believe that a particular RepInfo object is well understood by the target users. A RIDO can have up to 3 children in its graph label, one of each of the OAIS categories: semantic, structure, and other. To add multiple children of the same category, we can add an AND node to the graph, as is done here. In the RepInfo Toolkit, RepInfo network models are listed under their own folder in each preservation project in the Project Explorer panel. So to open a model, we just double-click it. The tool has a graphical canvas on which RepInfo networks are drawn. There is a panel of base objects that can be dragged into this to add more objects to the graph. A right-hand panel shows properties of the currently selected object, and a debug window shows what's going on. So let's look at a very simple network which consists of a single RepInfo data object, or RIDO. This can contain details of a concrete RepInfo object and/or information about the graph label whose structure describes the object in terms of other RepInfo objects. Having selected this, we can see its properties in the Property panel. This RIDO has details of a RepInfo object, the properties that begin with RI. We see the name, its reference, which is a locator for the object itself, its tags, which are a list of OAIS categories, an ID, version, and the name of the registry that holds the information about the object. These last 3 properties are assigned by the tool or come from the source registry, and we can't change them directly here, but we can edit the name, reference, or tags here if we wish. Here we have a small RepInfo network that consists of a single graph label. The top RIDO contains details of the graph label, properties that begin with graph label in the panel. This lists a name, a description, and a list of tags, all of which we can edit, and an ID, version, registry, and status fields that we can't edit directly, as these fields are maintained by the registry load and upload operations. Note that this RIDO has no RI details. That's okay. We'll see later that it could contain both RI and graph label details. The rest of the diagram shows the structure of the graph label. There are 2 children linked from the parent RIDO with arcs labeled structure and other. Each child is another RIDO. If we select one, we can see that it has RI details but no graph label details. In fact, There is a graph label in the registry associated with this RepInfo, but we haven't retrieved the information yet. We'll cover that in a later video on searching and expanding. This shows a larger RepInfo network. It's still a single graph label, but one with a little bit more structure. The middle child is actually an AND group with 2 Rido leaves. Remember that in a graph label, each Rido can only have one relation of each of the 3 categories: semantic, structure, and other. So to add multiple children, semantic children for example, you have to use an AND node like this. And each of the leaves of the graph must contain RepInfo details. Here we see a larger RepInfo network. This one contains more than one graph label. If we look at the netcdf example data Rido, this is a child in the top Rido's graph label, but it has a graph label itself in our network, so it contains both RepInfo details and graph label details. Note that in the other half of the network, the designer has used the missing RepInfo in places where they felt that there was no need to define the network any further. That's all I want to cover in this overview. Watch other videos in this series to learn how to find, create and edit RepInfo networks using the RepInfo Toolkit.